All right, let's do our normal model problems here. So these ones we have got, here we have this type of bread. We do know that we've got a mean cost and then we've got a standard deviation. So they average 350 with a standard deviation of 43 cents. So the most expensive is 3 standard deviations above the mean. So either take the mean plus 3 standard deviations or set it up with your little z-score formula where you put z is 3 because that's the number of standard deviations above the mean. So then the bread cost is X. Now, what proportion of breads cost less than $4? So see, that is your X. So you're going to get your z-score with your X minus the mean over the standard deviation, and then norm CDF, the area below. Proportion of bread costs more than this, so that is your X. So you're going to X minus the mean over the standard deviation and norm CDF, the area above. Here is in between 3 and 350. So we have got two X values. So we're going to take those two X values and get a Z-score for both of them. Notice that the upper Z-score is for 350, and that 350 is that 350 is or 0 because it is the mean, and then we're going to norm CDF the between those two z scores from those x's. All right, and then look here, the cutoff for the bottom 20%. So that's indicating to me an area below. So I inverse normed that area below is the z at that spot, and then I solved for the cutoff price at that bottom 20%. So, keep in mind if you are drawing a picture here, we want to solve for that where we have this 20% below. So we inverse norms to get that z-score, and then we solved. So for so many of these, if you drew a picture, then you can understand what's happening. Now, this was a very interesting one, and this is an AP question here. So we have this, we had two unknowns. So very interesting. So we had a situation where we know that we're 20% of the pipes were less than 966. So that you can see here, I put that right here in this section. So I did inverse norm of 0.20. So that is a z-score of negative 0.84 and the corresponding amount that goes with it is 9.66. All right. Then the second fact is that 30% of the pipes are above. So that's this top 30%. So look, I inverse normed 0.70, that area below, and that's a z-score of 0.52. And that corresponds with a diameter of 10.578. So now what you see is I have got two measurements. From here to here is a distance in inches, and from here to here is a number of a width in terms of standard deviations. So if you notice, what I did was I took 0.52 standard deviations above. Okay, so I did 0.52 minus negative 0.84 to see that this width is 1.36 standard deviations wide. That's what I have here. That width is 1.36 standard deviations wide. Now, how many inches wide is it? So 1.36 standard deviations wide is equivalent to 0.911 inches. Those are the inches wide. So that allows me to solve for the standard deviation of 0.67. So then I know that I'm down to answer choice B or E. So now I'm going to come over. I'm going to pick one of these sides. I guess I picked the one with the positive numbers, and you could have done it at either site. You could have picked either one. There's the z-score. There is the diameter, and here is the just found standard deviation, and then you can solve for that mean. And so then there you go. So then you have your mean and your standard deviation. All right, now here we go with Rudy measuring these lengths. And so we are going to transform the data from inches or feet to from inches to feet. So we're going to need to divide by 12 or multiply by 12. Okay. I guess we're dividing by, yeah, dividing by 12. Okay. So both mean and standard deviation are affected by division. So I do just divide them both. All right. Next, what percentage of observations fall within 2 standard deviations for each of these populations? Very interesting. So one of them is wider than the other. But regardless of it being wider in context, it's still 2 standard deviations wide. And 2 standard deviations wide is going to be 95% of the data, regardless of contextually how wide it is. 2 standard deviations is going to contain 95% of the data, regardless of how contextually wide they are. And here we have the noise level at the 99% is below what? So I had to find out the z-score at the 99th percentile. So that's your 2.33 is your x minus mean over standard deviation. So then I solved for the x. That's what was unknown. Now look here. With this one, we have got the, let's scoot that on over. So here on this one, we have got the eldest 18%. So that is the top 18% of people will live to be 120 or more. Okay, so then the question is, what is the standard deviation? We have the mean, and so I can figure out the z-score at this spot because I know that it is going to be inverse norm of the area below, and the area below is 0.82. So when I did inverse norm of 0.82 in my calculator, that's a z-score of 0.92. So that's how I do that, and 120 is my x minus the mean over this standard deviation is what I'm solving for. Okay? All right. Then here we have this. The biggest thing that I find my students make a mistake on this one is only overflowing. So that is a top part. 0.005 is the top part here. So I have to inverse norm, look here, 0.995, which is 2.58. So that is the z-score that I set it equal to. And 8 ounces is the cup size, and I'm solving for the mean. So that's how I get that they should set the mean of the machine equal to 6.968. Now 34 is interesting. It's the pygmies. Look, here's a picture of the pygmies down here. Okay, and so we have some criteria. Taller than 48 inches. Okay, so we had to convert from feet to all inches. So I did. Taller than 48 inches. The mean is 51 inches. So my z-score is x minus the mean over the standard deviation, and then I norm CDF'd above that. Now, we wanted to know who is left out. So if you look at my picture, this yellow part is the people who get to sing, but it's the ones to the left who are left out and the ones to the right who are left out. So you could do this one of two ways. You could either identify how much this yellow is, or you can, and then subtract that from 100%. Or you could compute the left and then compute the right and add those together. So regardless, I got the 2 different z-scores, one for 50 inches and one for 54 inches. So here are the z-scores. And apparently it looks like I got this. So 62.47% of them get to sing. That's the yellow part. So I subtracted that from 100. Now, again, you could have just figured out the left area and the right area and added those together to see who does not get to sing. And the last one, top 10%, that's your inverse norm of the 0.90. And so then that's how you get that there. All right, I believe that is all of these problems. I hope that you review or remembered these normal model problems, and that's bringing back how to do all those specific things that it asked for. So good luck to you on your units 1 through 3 quiz.